Well, welcome back. In this screencast, we take a look at the closest thing we're going to get to division. Division's not a thing for matrices, but we can multiply by an inverse, and we're going to take a look at what exactly that means. To talk about an inverse of a matrix, we have to talk about what the identity matrix is. And the identity matrix is a square matrix that has ones on the main diagonal and zeros everywhere else. It's got ones on the main diagonal and zeros everywhere else. That is the identity matrix. It's a square matrix. You can't have an identity matrix that's 3 by 4, but you can have one that's 2 by 2 and one that's 3 by 3 and one that's 5 by 5 and so on. It's got to be square. Ones down the main diagonal, zeros everywhere else. So when we look to find the inverse of 1, 7, 2, 3, when we look to find the inverse of that, we are looking to find the matrix so that 1, 7, 2, 3 times whatever this inverse matrix is equal to the identity, 1, 0, 0, 1. Why? Because when we go to find the inverse of 6, the multiplicative inverse of 6, 6 times whatever the inverse is the identity. And that's why the inverse of 6 is 1/6. That's the reciprocal. What we are finding is the matrix that functions as a reciprocal would. Because when you multiply a matrix by its reciprocal, you end up back where you started. So reciprocal is particular to our studies with fractions. Generally speaking, we're thinking about inverses, multiplicative inverses. So what does this all mean? Well, first row times first column, 1 times A plus 7 times C is equal to 1. And 2 times A plus 3 times C is equal to 0. And this is a system that can be solved. And then similarly, first row times second column. First row times second column. 1 times B plus 7 times D is 0. And 2 times B plus 3 times D is 1. And this is a system that can be solved. In fact, take a moment and solve both of those systems. They're a little bit messy. Okay, so if you were careful to solve the system, those are the A and B and C and D that you get. And so the inverse is negative 3/11, 7/11, 2/11, negative 1/11. Now, most calculators have a way to find an inverse matrix because most calculators have a way to enter a matrix. So let's see, you may not have a calculator like I do, but I can create a matrix that's 2 by 2, 1, 7, 2, 3, and then I want to find the inverse of that matrix. And the symbol for inverse is the negative 1 power, and sure enough, A and B and C and D are just like we thought they would be. Now, if the matrix is 2 by 2, no problem. If the matrix is 3 by 3 or higher, well, that's a problem. Let's find the inverse of 1, 2, 3, 2, negative 1, 5, 3, 0, 4. Let's find the inverse of that matrix. How do we do that? Well, the way we can do that, as you read, is to take this matrix and append, augment an identity matrix. And this identity matrix has main diagonals, off diagonals. The main diagonals are 1, everything else is a 0, totally fine. So we put the matrix whose inverse we're trying to find over here, we put an identity matrix over here, and then we try to put this one in reduced form. Well, how do we put this one in reduced form? We use the same operations we've been using for Gauss-Jordan elimination. We want a 1 there, and we've got it. We get some zeros here. So row 1 is going to stay the same. Then we're going to do -2 of these plus that. -2 of, that's -4 plus that. -2 of those is -6 plus that. -2 of those plus 0, that's that. -2 of those plus 1, -2 of those plus that, and then -3 of those plus that, 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 -3 of those plus that. And the more we do this, when we get this into reduced form, 1's down the main diagonal, 0's everywhere else, whatever is over here will be the inverse. Take a minute or two, hit the pause button, get the left matrix into reduced row echelon form. Okay, so hopefully you'll be able to follow some of my work here. It was clear twice row 1, add it to row 2, 3 times row 1, add it to row 3 to get zeros there. And then we wanted a 1 here, so everybody got multiplied by -1/5. And then we wanted a 0 in this spot, so we took 6 of those and added here. And then we wanted a 1 in this spot, so everybody got multiplied by -5/19. That's where all the 19s come from, because to get this to be a 1, everybody gets multiplied by -5/19. And then we're almost done. We're in row echelon form. We've got 1s on the main diagonal and 0s below it. But then we need reduced row echelon form, so we get a 0 here, -1/5 of row 3 plus row 2, leave it in row 2. And this gets us all the way home. I didn't take it all the way, but we certainly could have, and if we did, we would end up with this matrix. And this matrix is the inverse of 1, 2, 3, 2, -1, 5, 3, 0, 4. If we multiplied 1, 2, 3, 2, -1, 5, 3, 0, 4 by that 3 by 3 with the 19s in the denominators, we would end up with the identity matrix. So this is a way to find inverse matrices without a calculator, but it is admittedly very, very tedious. So when we gather, I'm going to make sure that we know how to do the process, how to append the identity matrix, augment with the identity matrix, and then step by step produce a reduced matrix on the left that will generate the inverse on the right. We'll practice with some 2 by 2s, and we'll practice with a 3 by 3 so that we know what we're doing, and then we'll try to apply it. All right, we'll see you when we gather. Thanks so much.